session on disproportionation reactions. Most of the disproportionation reactions happen in basic medium, and we also try to learn balancing ionic equations during the course of a disproportionation reaction. What is disproportionation reaction? Disproportionation reaction is a type of redox reaction in which the same species is simultaneously oxidized and reduced. One species that undergoes disproportionation is cuprous ion. They have given in the net. 2 units of cuprous ion can undergo disproportionation. One cuprous ion will become copper where it is reduced, and another cuprous ion will become cupric ion where it is oxidized. You see, they give electrode potentials also, if you are aware of this. More is the electrode potential, more positive value it has, more likely to happen. Cu plus 2 is gaining 1 electron to give cuprous ion, when that electrode potential is 0.153 positive. Cuprous ion is gaining 1 more electron to become copper metal, for this electrode potential is 0.521. That is more likely to happen. Now, what do you mean by overall reaction? By overall reaction means these 2 cuprous ions partially undergoing oxidation and reduction. You know that electrode potential is not an additive property, but delta G is additive property, and you know how to solve this problem, I believe. First one, the half reaction is this. And next, so you can see this of reactions, and if you follow my previous lectures on electrochemistry, you can easily see to it how we got it. And of course, the overall reaction for 2 cuprous to become cupric and copper, electrode potential is highly positive. And from this you can work out delta G will be largely negative, and K value is also more than 1. It means cuprous ions indeed can undergo disproportionation. But at the moment my interest is to say, what is disproportionation? A reaction where the same species, for example here, chlorine which is 0 is becoming Cl minus, means that is gain of electrons, that is reduction. The same Cl0 is becoming ClO3 minus. In ClO3 minus, as you know very well, in ClO3 minus, Cl, if you say oxidation state is X, 3 oxygens, each one is minus 2, overall charge is minus 1, X minus 6 is equal to minus 1, X is equal to minus 1 plus 6, X is equal to plus 5. The oxidation state of Cl in ClO3 minus is plus 5. It means the Cl0 became Cl plus 5. It means it lost 5 electrons, oxidation. So when chlorine is kept in a basic solution which is hot and concentrated, chlorine is undergoing partially reduction, partially oxidation. This reaction is called disproportionation. Similarly, if you put phosphorus P4 in a basic medium, OH minus, partially it becomes pH3, where P0 became P minus 3, and also P0 became, in this hypophosphite ion, phosphorus is plus 1, that is oxidation. So the same species is undergoing reduction and oxidation. Similarly, chlorine in a cold diluted base will become Cl minus and ClO minus. In ClO minus again chlorine is plus 1. So you can see it is reduction, you can see it as oxidation. If both things are happening to same fellow, then that is called as disproportionation. Normally phosphorus, chlorine, bromine, iodine, sulfur, all these fellows can undergo disproportionation in basic medium. Main theme of this present lecture is how to balance a disproportionation reaction in half reaction method. Let us take for example Cl2 in a hot concentrated basic solution becomes Cl minus and ClO3 minus. How to balance it? I tell you, same thing you divide into two parts. You take one Cl2, that gives Cl minus. You take another Cl2, that gives ClO3 minus. You have divided into two half reactions. Now you balance atoms other than oxygen and hydrogen. Two Cls, here only one. So you write Cl2 gives 2Cl minus. Here 2Cl, here 1. Again Cl2 gives 2ClO3. That is our first step. First separate and then balance atoms other than oxygen and hydrogen. Then here there are oxygens. Here there is no oxygen. So I need to balance. Here there are 6 oxygens. Here there are no oxygens. Side where there are no oxygens, add enough water. Again you have a problem. Here you have hydrogens, 12 hydrogens. Here there are no hydrogens. To balance hydrogens, side where there are no hydrogens in basic medium. Here there are no hydrogens, right? So the side where there are no hydrogens, you will add as many hydrogens are deficient, 12 hydrogens as water. Opposite side, same number of OH minus. All these steps are not required here. So let us translate this. The last step is balancing the charges. Now let us look at that and balance the charges. To balance the charges, here you have 2 minus charges, here there is no minus charge. Side where there is no minus charge, you will add electrons, you will add 2 electrons. Now these charges are balanced. Here it is looking a bit complicated. Here you have 12 minus charges left side. Here you have 2 minus charges, 2 ClO3 minus. 12 minus, 2 minus means right side 10 minus charges are deficient. So I will have to add 10 electrons on the right side. Before I do, here I can see 12 waters, here 6 waters I can cancel. So I can have 6 waters on the right side. Now what I do is Cl2 plus 12 OH minus. Here there are 12 minus, gives 2 ClO3 minus. Here there are only 2 minus and 6 waters. Because here I have 10 electrons, 10 negative charges deficiency, I add 10 electrons. Now, in this half reaction, 2 electrons are gained. This I call as the reduction half reaction. In this half reaction, 10 electrons are lost, so I can call it as oxidation half reaction. Don't worry about that. Reduction half reaction, oxidation half reaction. Now I have seen that this has 12 electron, 2 electron gain, 10 electron loss. To equate it, multiply it with 5 and then add 5 Cl2 plus 10 electrons gives 5, 2s are 10 Cl minus. To this I will add Cl2 plus 12 OH minus gives 2 ClO3 minus plus 6 water plus 10 electrons. And we add. If I add, I am getting 5 plus 1, 6 Cl2 plus 12 OH minus plus 10 electrons gives 10 Cl minus plus 2 ClO3 minus plus 6 H2O. These electrons are getting cancelled. This is the entire equation can be happily divided with 2. So that I get finally 3 Cl2 plus 6 OH minus plus 5 electrons gives. No, electrons are getting cancelled. I am sorry. By mistake I wrote. Electrons got cancelled. I will not have to write this. This is a mistake. Sorry. 3 Cl2 plus 6 OH minus gives 10 Cl minus plus, 5 Cl minus, because I am dividing throughout with 2, plus ClO3 minus plus 3 water. This is a simplified final equation. Okay. This way you can balance the disproportionation reactions, stepwise process. But always better to adopt shortcut method, which I have said earlier. Shortcut method is only one line method. You can recall Cl2 gives Cl minus plus ClO3 minus. You can see here one Cl is becoming Cl minus. You can write it as 2 times in shortcut method. It is shortcut. And this Cl is becoming ClO3 minus, where Cl is plus 5. Now here it is minus 5 means Cl minus means 1 electron is gain. So a 1 electron gain reduction. Here 5 electrons are lost oxidation. Now what I should do is equate the number of electrons lost with gain. So here gain is 1 now, multiply it with 5. So here also you will multiply with 5. Now you don't disturb. 5 electrons gain, 5 electrons lost, because I multiplied with 5. Now here I have 3 oxygens, here no oxygens. Basic medium or acidic medium, oxygens are less means as many oxygens are less, as many waters you add. Fine. Last step in basic medium, to balance hydrogens. Here you have 6 hydrogens, here you have no hydrogens. So as many hydrogens are less, write as many waters on the side where there are no hydrogens. Opposite side, same number of OH minus ions. That's all. Now your work is done. If you cut the equal terms, 3 waters you cut. Now your final equation is there in shortcut method. This is 1 Cl. Here you have 5 Cls. Put together 6 Cls, 3 Cl2. Here you have 6 OH minus, okay. Gives Cl minus plus ClO3 minus plus 3H2. This is shortcut method. Okay, better go for this. Anyway, good luck.